Hello everyone. So whatever we had discussed in the last class, we will now move ahead of that. So as we are discussing that we considered the case when one of the surfaces, plane surface, which is inclined to at one of the reference planes. So that case we had actually discussed in the last class. So today we will now consider that suppose it is having inclination with both the reference planes, and for such conditions, as I mentioned last class also, that in order to express it in the form of text, uh, generally it will be expressed by giving inclination of the surface with one of the reference planes and the inclination with other plane generally be given in terms of inclination of any edge of the plane with the other reference plane. Okay, so here one case has been shown in the next slide, or and that partly this was done in the previous one also. So it is like, to suppose if we have to draw projections of a plane figure whose surface is inclined to oh sorry, so this is the general statement, right, what I was discussing, and this second one is giving you the case where the plane figure is inclined to the horizontal plane. It's one of the shorter edge is parallel to the HP, and that shorter edge is making an inclination with the VP. Okay, so this is what is actually explained. This part is not going up. Yeah, now it's gone. So yeah, so the three cases are shown over here, right? So what we discussed in the last class yesterday, that was this one and two, these two only, and this has got this third also. So to begin with, what actually was mentioned in the previous slide, that the surface, that is plane surface, which is for this case rectangle, is inclined to horizontal plane, and one of its edges is parallel to the horizontal plane, and that edge is inclined with the vertical plane. So you can have a look at this final figure. Here what's happening, this plane figure is inclined to the horizontal plane, right? Let me change this to pointer option, as you guys were mentioning in earlier class. Yeah, right. So let us get back to this. So if you see this third diagram here, so we have a plane figure, that is a rectangle for this case. It is inclined to the horizontal plane, and one of its shorter edge, this one, this is parallel to the horizontal plane and is making certain inclination with the vertical plane. So this edge is parallel to this horizontal plane, but this is making inclination with the vertical plane. So this line is drawn over here just to depict that this shorter edge is inclined to the vertical plane. Okay, so we have to finally reach this position, right? So for this, we'll actually obtain this in these three steps: 1, 2, and 3. Okay, so here you have the pictorial representation, and here whatever orthographic views, that is front to top view, we will have. So now have a look at this, how we have drawn, how we have considered its placement in the first position. This plane figure is parallel to the horizontal plane, right? In the final figure, this plane figure is to be inclined with the horizontal plane, right? But in the first one, what we have done, we have kept it parallel to the horizontal plane. So one thing we had discussed last class, that to begin our drawing, first of all, to begin the drawing, we'll need the true shape, because the true shape will allow us to draw it properly on the drawing sheet. For the inclined position, whatever we have here, we will not have the true shape, right? Rather, we'll have some what do you call, some reduced lengths. Okay, so that is why we'll begin with such a view that we can have the true shape available. So that is one thing. Also, the surface is inclined with the horizontal plane, so we are beginning by keeping the surface parallel to the horizontal plane, right? Next, there is one short edge which is remaining parallel to the horizontal plane in the final view. This is remaining parallel to the horizontal plane in the final view and is maintaining inclination with the vertical plane. Okay, so here what we have done, we have capped this edge perpendicular to the XY line. Eventually, that makes this edge perpendicular to the vertical plane. Okay, and the advantage we had discussed earlier also, this edge now gives us a point view. Both the endpoints are coincident in the front view. Okay, so this is the first step. So first step, you'll find that it will remain crucial many times, because we cannot commit a mistake here, right? So when we have to draw it in the second step, then we try to achieve the condition that surface is inclined with the horizontal plane. So since we had a line view for the surface available here in the front view, we can draw the line view inclined to the XY line, and this will amount to making the plane figure inclined with the horizontal plane. Okay, so that is what done in the next step. One more thing here is noteworthy, that when we are doing this thing, we need not change the position of this A dash B dash, right? That is the point view of this edge, shorter edge, which we intend to keep parallel to the horizontal plane in the final view. So this need not be changed. Rest of the line will be drawn at a separate inclination. This point remains wherever it was. So what will happen? This edge here will still be parallel to horizontal plane, will still give us the true length, right? This edge only will give us the true length, but these two now are reduced in length, and therefore overall reduced shape of the top view is obtained. Then in the third step, we have to obtain that one of the edges of the plane figure is parallel to the horizontal plane and inclined with the vertical plane. So now this thing we have to draw by keeping this edge. This edge is giving true length. Of course, for this figure, this is also giving the true length, and this is also remaining parallel to the horizontal plane. Some of you might be already thinking like that, right? But this may not be the case for every possible plane figures, right? For this one, this is occurring so. But anyhow, in any case, if as long as you have kept it in its position over here, this in any case will remain parallel to the horizontal plane. So here, this one which is parallel to the horizontal plane, this has to be drawn at the desired inclination with the XY line. Suppose the, we have the condition that this is inclined, this edge, one of the shorter edge is parallel to the horizontal plane and inclined at 60 degrees to the vertical plane. Then what we'll do, we'll draw this at 60 degrees here, and then rest of the figure we'll reproduce whatever top view we have here. that has to be reproduced here by keeping this relevant edge at the desired inclination of the xy. If we keep this at 60 degrees with xy, that will amount to this edge being capped at 60 degrees with the vertical plane. Okay, so we have this, and then after redrawing this, we'll draw all these projectors upward from all the corners, right? And correspondingly, we'll draw the relevant lines parallel to the xy line from this previous figure, and the intersection points like this line from here and this one projector from this A. The intersection gives us the A dash. B dash will be obtained by drawing this line and this line, and the intersection gives B dash. And likewise, these two will also be located. So this gives us the final front view and top view. Uh, Here, one thing let me mention, as we are doing these two operations, that is from 1 to 2 and then 2 to 3. So you see, for this case, what we did is initially we had drawn this true shape in the top view and a line view we obtained in the front view. Next, what we did, we have drawn the line view inclined at certain angle. Now you see, when we do so, then what happens is this amounts to rotating this plane figure, right? This by step 1 to step 2, that is when we are drawing the front view like this. Then this amounts to rotating this plane figure by keeping this edge at its own location and shifting it to this. So when this change will take place, then you can see the distances of these points, this corner point, this corner point, this corner point, this corner point. So distances of all these corner points from the vertical plane will remain same in this figure as well as in this figure, right? The distance from here up to this vertical plane, this is not getting altered. Distance of this corner from this, it's not getting altered, although its position is being varied. It is now being uh, tilted, but is still these distances are not getting altered. That is why we can simply draw these lines, right? And consider that these will contain this A and D. From here I draw a line and consider that this line will contain A and D. Because of this reason, that the distance of this corner and this corner from the vertical plane in this figure as well as in this figure, these two will remain same. Okay, and same goes for this B and C, which will be along this line, because their distance from xy line will remain same in this figure also and in this figure also, because their distances here and here are remaining same. Okay, same way for the third figure, what we are doing is we actually are redrawing this top view in this position. The same thing is being redrawn by keeping this at certain desired inclination, and this will amount to rotating this plane figure, right? Rotating this plane figure by maintaining same inclination with the horizontal plane. Okay, let me repeat. Redrawing this top view in this third step by keeping this line at certain inclination, right? This will amount to rotating this plane figure, right? Like this, and making this, obtaining this inclination of this short edge with the vertical plane. And while doing so, while this rotation is carried out, the inclination of this plane figure with the horizontal plane does not get altered. Okay, so that is what we do in this. Okay, so if any of you have any doubt, then please you can type it in. Okay, so a doubt I could see about the third step. So you see, what I'm saying is, for reproducing this from second step to third step, right? What we are doing is, this distance, this age, we are keeping at desired inclination with the XY line. Suppose it is to be kept at 60 degrees. Thereafter, you have to redraw this. Now, probably redrawing will be, let me explain that also. So, what you can do is this thing you reproduce here, line, right? A1, B1. Of course, this we can do directly by keeping it at whatever inclination. The length already is known to us. Thereafter, say in this figure, suppose from this end point you measure distance for this, from this end point you measure distance for this, and then say you draw two arcs and locate D1 here. From here you draw one arc with this length. From here another arc with this much length, and you look at this. Okay, the same can be done from this distance measured, one arc drawn here. From here again another arc, and then this located. This measuring the distances and drawing the arcs and intersection, locating the corners. This I specifically mentioned because here it will be easy to reproduce it, of course, because it is a rectangle. But when it is not so, then the inclinations might not be very much convenient to take and redraw, right? So this probably will give faster locations. I mean, you can locate the corner points faster by taking these distances and drawing arcs with compass and intersecting. Other possibility could be that each thing you measure the length for each edge and then reproduces. Yeah, some more doubts. I'll just read it. How much to rotate A1 D1? I explained that we are considering that A1 B1 only is being redrawn to some particular location. Then rest of the figure you are reproducing. So that you will get by default by measuring all the distances. Then there is one from 1 to 2, A dash B dash C dash D dash line in 1 also remains same as A dash B dash in 2. Yeah. I'll maybe just uh, retell the whole thing in a little fast speed, and then we can see one or two examples that will anyways clarify things. Okay, so what I mentioned, first of all, we have been given the condition. This is what we have to achieve, right? So we have a plane figure which is having one of its edges parallel to the horizontal plane and inclined to the vertical plane. One of the edges of the plane figure is parallel to the horizontal plane and inclined to the vertical plane. One thing. Second thing is the surface of the plane figure is having some inclination with the horizontal plane. So these are the two conditions which are given to describe the positioning of this plane figure in this third diagram. So how do we begin with this? First of all, we keep this plane figure parallel to the horizontal plane. That allows true shape to be available in the top view. So that is what is done, right? What we are doing is we are simply drawing the true shape of the rectangle over here with the available dimensions. Fine. Also, while drawing this true shape, what we are doing is we are considering one of the shorter edges perpendicular to the XY line. Okay. By doing this, we ensure that this edge actually will remain perpendicular to the vertical plane. You can see it here. It will be perpendicular to the vertical plane. The advantage with this is this A and B both will be coincident and a point view will be obtained here. So keeping the plane figure parallel to horizontal plane, right, by default we end up making it perpendicular to the vertical plane. That is one thing. So we get a line view here. Second thing is if we keep this shorter edge perpendicular to XY, then this gives us a point view over here. Fine. Keeping this AB perpendicular to XY or the shorter edge perpendicular to XY is essential because once we obtain a point view in this for this edge, then only it is possible that we can rotate this line view about this point view while keeping this edge at its position, right? So when we rotate this without altering this location, then what happens is this A dash B dash remains here itself and this one inclination of the surface changes. This line rotated, this line actually is the plane figure. So what is happening? Now here it is making some inclination in the front view with the XY line. That means the plane figure in actual will make inclination with the horizontal plane. What is depicted here? Okay. So that is the second thing. Now corresponding to this we can obtain the top view. For obtaining the top view what we are doing is we are supposed to draw, so first of all, projectors from these available front view. So C dash D dash located here, we draw the projector. A dash B dash here, we draw the projector. Next what? When this is done, that is this thing, this line view is changed to this kind of orientation, right? Inclination is given. When this change takes place, then we actually are only rotating this front view from here to here. So this plane figure, this change that is from this front view to this front view, the change whichever is occurring, that actually will correspond to inclination of this plane figure with the horizontal plane, but at the same time the distance of this plane figure from the vertical plane is not getting altered. Okay, so like this corner point has some distance from vertical plane, here also it will have the same distance. This corner point, whatever is distance here, it will be exactly same what was earlier existing, that is from here to here. So making use of this fact, in the top view, wherever all these corner points are located, their distances from the XY line in the first figure and their distances from the XY line in the second figure, they'll remain just the same. So what we have to do is we have to actually continue on the same XY line as we proceed from 1, 2 and to 3. This transition as is occurring, we keep the same XY line. So whatever are the distances from XY line for A, B, C, D here, the same distances will be available here also from this XY line. Okay, so that is why these loci of these points have been drawn over here. Okay, from here to here, from here to here, and thereby we are locating on, say, A and D will be on this locus, B and C will be on this locus. Other than that, we know that A dash B dash will be on this projector, C dash D dash will be on this projector. Okay, so these intersections, A dash is to be on this, A is to be on this, so common intersection locates A1. B dash is to be on this, B is on this locus, so B1 here. C dash is on this and C here is on this. So intersection gives this. Likewise, you look at D1. So like this reduced top view is then obtained. Okay. Now from position 2 to 3, what we are doing is we are trying to obtain the final position. For this, what here actually what we have achieved is the inclination of the surface as per the given condition obtained. This is inclined, the front view is inclined with the xy line. So plane surface is having whatever inclination we wanted to achieve. But apart from that, we have the condition that this one shorter edge is parallel to the horizontal plane. Yeah, of course, it is still parallel to the horizontal plane. We did not alter it, right? It is remaining at the same location in the front view. So this is still parallel to the horizontal plane. But it is supposed to be inclined with the vertical plane in the final view. So that inclination now, whatever is the inclination, that has to be now achieved. Now suppose that inclination of this edge with the vertical plane is 60 degrees, suppose. Then what we have to do is this complete plane figure we have to reproduce here by keeping this edge at 60 degrees to the xy line. When we do so, this will amount to making this edge 60 degrees to the vertical plane, whatever is seen in this pictorial representation, this thing. Okay, so that is one thing. And thereafter you have to reproduce rest of the corner points, right? So the same figure, whatever is here, will have to be redrawn. Okay, fine. And for this, I mean, some people were saying how to do or whatever. So I mentioned that you first of all draw this. For this, you know the length. You draw this and then measure the distance, say for D from this A and C from this A, and then these distances from B, and then draw the arc. So you measure A1 D1, and from this as the center, you draw one arc. You measure B1 D1, draw another arc from B1. Intersection will locate D1. Like that you can locate all the corners. As you join them, your top view here in the second step will be redrawn. Redrawing the top view in this fashion amounts to rotating this plane figure and making it attain this position. And this rotation from here to here, the same size of the top view is being rotated. This eventually means what? Inclination of this plane figure is same with the horizontal plane. Then only the same top view we will achieve for here and here. Okay, so that is the idea. Here whatever is the inclination, the same inclination is to be maintained here. Only this edge is to be at certain inclination. So to achieve this here on drawing, what we need to do is we need to redraw this at certain inclination. So redrawing by maintaining the same shape and size will mean that we are maintaining the same inclination of this surface with the horizontal plane. That will be ensured by doing this. Now when we are doing this thing, then of course all these corner points for this plane figure, their distances from the horizontal plane for this case 3 and for the case 2 will remain same because the inclination of this plane figure with horizontal plane is not altered from step 2 to 3. So the corner points maintain the same distance from the horizontal plane here also and here also. So making use of this fact, what we do is we consider this A dash B dash which were maintaining this much distance from XY line here, they will continue to actually remain at the same distance here also. Okay, so that is why this locus can be drawn for A dash B dash, and of course A dash B dash will be on their respective projectors. So from A1 you draw projector, from B1 you draw projector. Okay, and then their intersection with A and B will give us A1 dash B1 dash, and then the same goes for the C and D. Their distance here from XY line is same as that of C and D in this figure. Okay, right. So rotation of this brought it to some other position, but their inclination of the plane from HP is remaining same. Location of the shorter edge, distance of the shorter edge from the plane remains same. So that is the thing. Now, I think let us move on to one example. Here we have considered the case when one of the shorter edge is parallel to horizontal plane, and then how do we obtain it, I mean, in the final view. The opposite case is there, then the same thing has to be repeated by obtaining the true shape in the vertical plane and keeping one of the edges perpendicular to the horizontal plane. Okay. So I have tried to write down those steps also so that you can read them on slide later on. Now let us consider this example. I guess if all of you please read this and then try to uh, follow it, then I think it will be more clear whatever we are doing. So we have say a 30-degree, 60-degree set square and with the longest side 100 mm is in VP. So this statement means the longest side of this set square is in the VP. Okay. And 30-degree inclined to HP. So the longest side is in VP and is 30-degree inclined to the HP, while its surface is inclined 45 degrees to VP. Okay, draw the projections. So now you can try to visualize how is it located. So you can assume the set square, triangle of course, right? It has got longest edge in the vertical plane, and that longest edge is actually making 30 degree to the horizontal plane. Apart from that, it is, yeah, please, if some of you are not recalling a set square, you have in your compass box a set square. Some question flashed up, what is a 30-60 set square? Set squares you have in your compass box. Use everyone who have used so far, right? So it will be say effectively a triangle which will have one angle 90 degrees, one angle 30 degrees, and one angle 60 degrees, right? So right angle triangle, one angle 30 degrees, one angle 60 degrees, and one edge given. So of course you can draw this triangle, right? So you can draw this triangle, that much I consider, right? Now next is to consider how is it placed, right? So first of all, it is longer edge, whatever, oh, sorry, longest edge is placed in the vertical plane. Longest edge is inclined 30 degrees to the horizontal plane, and the surface of the set square is inclined 45 degrees to vertical plane. So you can try to imagine how is it located in the first quadrant with the longest edge in the vertical plane. Okay, I'll pause for say a few seconds. You can try to imagine. Okay, so now you see the surface is making some inclination with the vertical plane, and one edge is actually lying in the vertical plane. So that is the case with us. Now, see, to achieve this final position, right, we have to actually obtain it using the front view and top view. That is what we will be drawing sequentially. So for that, our initial position is to be such that, first of all, we should be able to draw the plane figure. That is number one thing. Then in the uh, following steps, we should be able to obtain the inclination. Yeah, no, I have not changed it. I'm just briefly discussing and then we'll see the solution. I have not, so that is why screen is not frozen. Yeah. So now what we have to achieve is, first of all, in the first step, true shape should be available. That is one thing. Then we have to obtain inclination of the surface of the plane figure, and we have to obtain the inclination of this longest edge with of other plane. Okay, so these three things have to be obtained. Now, if this longest edge is to be maintained in the vertical plane, Okay. So first of all, what we will have to do is, first of all, assume the complete thing to lie in the vertical plane. Number one thing, so true shape will be available in the vertical plane. Number two, we will have to obtain the inclination of the surface with the vertical plane, right? It will be easier if the top view is a line view, right? If the top view is the line view, it is easier, as we discussed in the previous. So that is second thing. And then in the last step, we have to obtain the inclination of longer edge with the horizontal plane. Okay. So now we can have a look at the solution. This steps you can read up if you need later on. This XY. First of all, this is the front view. So we have considered it to lie on the vertical plane. Okay. Now you see what has been done. The longest edge has been kept perpendicular to XY. Right? Why so? Because longest edge is supposed to be lying in the vertical plane in the final position also, right? So it is kept but perpendicular to XY. Now we have if we assume it to be on the vertical plane, then on the XY line we can obtain the top view. Okay, so A and B are coincident and C is obtained here, right? So now you see it is, to obtain this 45-degree inclination is possible when we rotate this C about AB. So AB will not change its position. So this thing will continue to remain in the vertical plane. Okay. So let us see in the next figure. We draw this at given inclination 45 degrees. Okay. A and B is still remaining on the XY line. So AB is still in the vertical plane. Okay, and C of course is now at this new position. Fine. Now corresponding to this, we can obtain the front view. Front view will get reduced in the size, right? And of course, when we are changing this thing, so what we are doing is we are making the surface of this set square inclined with the vertical plane, but the position of these corners from the horizontal plane we are not changing. So therefore, the B dash will maintain the same distance from XY line, C dash will maintain same distance from XY line, A dash will maintain same distance from XY line. Okay, and then drawing these projectors from A, B and C, we locate the reduced size. Okay, this so here's inclination of surface is achieved, right? Here, first position, we ensured to obtain true shape, because if we don't have the true shape visible in any of the views, with this given information, we won't be able to draw this, right? Here, you simply draw this 100 mm line, a 30-degree line from here, a 60-degree line from here, and you look at C dash, and the triangle is complete. That is the first step. A dash B dash is to be kept perpendicular to XY in the first step, so that this gives a point view here. This point view helps us in what? When we want to achieve inclination of the surface of this set square with the vertical plane, what we need to do is we need to have the top view drawn inclined with the XY line. Okay, this line view, the top view is a line view. It is to be drawn inclined with the XY line, and this gives us inclination of this surface. The condition that this surface is inclined is achieved. And corresponding to this, then we obtain the reduced front view. Next, what we have to do is we have to obtain this A dash B dash with some inclination. How much? Is 30 degree. Okay, so this longest edge which is in the vertical plane is making 30-degree inclination with the horizontal plane. So this we have to redraw now here. So we'll redraw this third one here, right, at 30 degrees to XY. and then you have to reproduce the triangle. When you do this, then this will amount to rotating this front view. This front view is rotated here in the third step, and that will mean the inclination of the plane figure is remaining same with the vertical plane, only its orientation is changing, right? So therefore, what will happen with this transformation? The distances of A, B and C in the top view from the XY line will continue to remain the same. Therefore, again we can have locus for AB on the XY and for C parallel to XY drawn from here. Then you draw the corresponding projectors and you can look at the final top. Okay. So our one of the the longest edge was to be in the vertical plane. You see, it is still in the vertical plane, and that is why its top view is on the XY line. Okay. So this is for this case of the set square. Now let us have a look at one more example, and then we can call it a day for today. This I have mentioned here, you can read it when you refer it. Yeah, this is the next example. So please go through it. I cannot repeat all the time. Actually, I'm trying to go very slow. I'm trying to go very slow and repeating again and again because of this online transmission delay or whatever. I try to remain very slow. But I mean, repeating so many times is not possible. Please go through the slides later on. Hmm? Now, let us maybe have a look at this example. Some of your doubts probably might become clear in this one, right? Yeah. So please, so we have to obtain again the projections of a regular hexagon of 25 mm sides, having one of its side in the horizontal plane and inclined at 60 degrees to the vertical plane. Its surface making an angle of 45 degree with the horizontal plane. So see, it is again similar case. The only thing is now plane figure is hexagon. So first of all, we have to choose the initial position such that we will be able to draw the true shape of the hexagon, and then the other view we have to obtain as the line view. So that is the easiest option, right? So here the surface in the final view, the surface is making an angle of 45 degree with the horizontal plane, right? So it is best if in the initial position we keep it parallel to the horizontal plane. Okay. Oh, sorry. So one of its side is in the horizontal plane, right? So one of the sides is in the horizontal plane. So it is best that we directly keep it in the horizontal plane. Otherwise, it will be the case where we try to keep the plane figure parallel to the plane. Okay. Mouse is stuck. Yeah. So yeah, we'll keep it in the horizontal plane. That is one thing. Secondly, see, it's a side which has to remain in the horizontal plane in the final view. This we will have to keep perpendicular to the vertical plane so that it can give a point view. When we keep the plane figure in the horizontal plane, we'll get the front view as the line view, right? The front view will become a line view. And we have to keep one edge perpendicular to the XY line in the top view so that this edge, which is to finally remain in the horizontal plane, will give a point view in the front. So that will be our initial position. XY line, and you have to draw plane figure on the horizontal plane. And here you see mouse. Yeah. So Yeah. So here you see this edge is perpendicular to XY line. Of course, it is a hexagon, so we'll have one more parallel edge. So this will also be perpendicular to the XY line. But of course, let us concentrate on this. So this is perpendicular to the XY line. So this gives us a point view in the front view. To draw this, of course, as I had mentioned, it is best if you use this angle made by this side on the center, right? So for hexagon, it will be 60 degrees. For others, you can always find out the slides you have. So you can keep the angle on your mind. So then what will happen from this geometry? You can locate the geometric center after drawing this side. This one side has to be kept perpendicular to XY. So first of all, draw this, look at the center, draw this circle, and on the circle locate all these corner points. So like that, if you draw, you will be able to draw a precise top view. Fine. Then you have to give some names, and now we can draw the projectors and obtain the front view, right? From all the corner points, we draw the projectors, we look at the front view. As we had discussed, this here we have A and B both on the same point. Now if I rotate this front view, then this will remain here itself. So this edge will continue to be in the horizontal plane. Okay, so what is the inclination? Its surface is making 45 degree with the HP. Okay, so in the next we have to draw it at 45 degree. Same thing drawn over here. And as considered in the previous time, while doing this, the distance of the corner points from the horizontal plane is not getting altered. So we draw the, oh sorry, distances from the vertical plane will not get altered for this case. So we can draw these locus for each of the corner points from here and the projectors from the front view. So then we'll look at the top view. So this intersection of F here and then F dash here, this locates F here. From A, we will obtain here, B, we will obtain here, D, we will obtain here. Okay, so like this, we obtain these corner points, and then we get a reduced top view. Okay, in the final view, this edge has to maintain 60 degrees with the vertical plane. So now this you have to reproduce here by keeping this AB at 60 degrees. Okay. Also, as I had mentioned, redrawing the top view is equivalent to rotating this top view, and that means the plane figure in the 3D it will actually be rotating, but the distances of the corner points from the horizontal plane won't get altered. So again, you can draw these locus for each of these loci for all the corners and the projectors from here. And you look at these. All the corner points, and it's done like this. So this is our final view. Okay, so with this I'll stop here. Some people express some doubts about the rotation and all. So what I'll do is now I'll stop the recording, and then I'll try to explain the earlier slide with the this pictorial representation again. So those who want to remain there, please stay there.